Okay, so Unit 5 lab. We were getting into actually predicting what a reaction will make. Okay, so slowly we're getting into things that are real chemistry. All right, so writing or drawing something that I did this weekend. Let's see. I'm a horrible drawer, so I'm just gonna write. I had family over. Oops. I had family over for football. So there was my mother-in-law, her husband, my husband's uncle, his great aunt. His family is mostly what lives out here. All right. So goals for today is you're going to learn how to predict the products of a single and double displacement reaction. Okay, and then from there we'll do some more balancing practice because this is a skill you need for your lab. Okay. As far as getting the lab, remember, head to the Dropbox area first. Okay. And this time I actually completely rewrote everything. So there's only one file. You just need to turn that file in, and it's both the procedure and the questions. Okay. Make sure you answer everything though. And points are listed in there. Okay. So this is stuff that you should already know how to do. Okay. So Group A columns on the periodic table. Those have easy, predictable charges. So let me magnify this a little so I have more space to write with. So the sodium falls in group 1A, so that's going to have one valence electron, which it'll give up and make a +1 charge. Okay, magnesium is right next door. It has 2 valence electrons. It'll give those up to make a 2+ charge. Okay, really pause the video and make sure you can do this on your own before I finish this, but if you're not sure, listen along. Chlorine is in group 7A, which means it has 7 valence electrons. Instead of giving up 7 electrons, we're 1 away from that octet that the noble gases have, so it's going to take on an extra electron, which would give it a -1 charge. Oxygen's in group 6A, so it has 6 valence electrons, 2 away from 8, so we're going to take on 2 electrons. Aluminum's in group 3A. Okay, so 3A, we're again closer to it's easier to give up 3 electrons than it is to take 5. So aluminum will make a 3+ charge. And nitrogen is in group 5A, so that's 5 valence electrons. So it's easier to take 3 extra ones than to give up the 5 it has. So that's going to make a 3- charge. Okay. Polyatomic ions, there's a list of these in the curriculum. You can also look up their charges online, but these are 4 that you'll be using in your lab. So hydroxide, OH, is a -1 charge, as does nitrate, NO3. Sulfate has a -2 charge, and phosphate has a -3 charge. Okay. Alright, so the point of all of these charges is so that you can cancel them out to form an ionic compound. So, using the information that you have, combine sodium and sulfate in order to produce a neutral ionic compound. So if sodium's +1, sulfate's -2, you're going to need 2 sodiums in order to cancel everything out. So it's Na2, little 2, so that it applies just to the sodium, SO4. Okay, so pause the video, try the other 2, and then start it back up and see if you got them right. So magnesium is +2, phosphate's -3. Whenever you run that 2-3 combination, the smallest common multiple is going to be 6. So it's going to be Mg3 to make +6. And then the polyatomic ions have to be put in parentheses if you're going to duplicate them. So it's PO4, 2. And then aluminum is 3+, chlorine is -1. So you'll need 1 aluminum and 3 chlorines to cancel out that extra positive. Okay, so this is the stuff you should already know coming into this. Information here is taking this information one step further. Okay, transition metals don't fall into the group A pattern. They don't have these standard charges, like, you know, everything in group 1A and everything in group 5A, that sort of thing. Many of them, in fact, can form more than one ion, like iron, copper, gold can form more than one, just a bunch of them. There's a few exceptions to that, and this information will come in handy for your lab. Okay, zinc will always be 2+ and silver will always be 1+. But when you run into these guys, iron, copper, transition metals that can form more than one, and you will see this in the lab, you have to use what it's attached to figure out its charge. Okay? So, for example, down here we have FeO, iron oxide. We know that oxygen is a 2- charge. Okay, which means, since there's only one iron attached to it, that iron has to have a 2+ charge in order to cancel that out. Okay? Then, iron nitride, we know nitrogen has a 3- charge, so that one iron must have a +3 charge, and actually I'm going to cross this one out because that wouldn't actually work. And then looking at copper oxide, we know that 2- is oxygen's charge, so the copper has to be 2+. Or chlorine, we know is 1-, except there's 2 of them, so that's a -2 charge. So this copper would also be 2+. Okay, that's something that you will have to use in the lab. So, now getting down to it. Actually dealing with the displacement reactions and predicting what their products will be. Key thing is that think of it always as the positive ions have to switch. Okay? So here we have iron, and it's going to kick something out of sodium hydroxide. Hydroxide we know has a negative charge. We know iron makes a positive charge, so iron's going to kick out the sodium. Okay? So that's going to make FeOH, and we'll come back to that in a second, plus sodium on its own. Okay? Now, iron can be +2 or +3. In this case, since it started out as neutral, we can't tell. So, honestly, I would just make it FeOH2, assuming that the iron was 2+. Okay? So now, to balance things, if you look at it, we have one iron on both sides. We have one sodium on both sides, but we have 2 hydroxides on the product side, so I need to put a 2 here. Now that's going to affect my sodium, because now I have 2 sodiums in the reactants, so I'm going to put a 2 out here for my products to balance. Okay. So next one, see if you can try this one on your own. So pause it and then start the video back up. But for this one, strontium's going to kick out the copper. Okay, so we're going to have strontium and SO4. We're going to come back to this, plus copper. Okay, and there's some lines for balancing when we get there. So strontium is in group 2A, which means it'll form a +2 ion. And sulfate, we know, is a 2- ion. So number-wise, it's SrSO4. We don't need to duplicate anything. So now we just need to go to balancing. We start out with 2 coppers on the reactant side, okay, and we have 1 on the product side, so we're going to need a 2 here. And then after that, you have 1 strontium, 1 sulfate, 1 sulfate, so it's balanced. Okay? Alright. And this should say double displacement. So a double displacement reaction, you have now, instead of a metal that's on its own, you have 2 compounds, and just think of it as the 2 positive charges are going to switch. Okay, so in this case, the first one, we have sodium hydroxide and magnesium chloride. The sodium and the magnesium are going to switch spots. Okay, so we're going to have MgOH and NaCl. Alright, magnesium is +2, OH is -1. So we're going to need to add a subscript to make sure that we get our overall neutral ionic compound. And then sodium and chlorine, we have +1, -1, so I don't need any subscripts there. once I have the ionic compounds formed with the appropriate subscripts, then I go to balancing. So, let's see, I have 1 sodium, but then I have 1 hydroxide and 2 hydroxides. So I'm going to need a 2 here. That'll fix my hydroxides, but that does mess up my sodiums now, so I'm going to need a 2 here. And then magnesium, I have 1 and 1. Chlorine, I have 2. And because of the 2 in front of NaCl, I also have 2 chlorines, so now we're balanced. So, last one. Again, pause the video, see if you can do it on your own. But the metals are going to switch, so copper and calcium are going to switch out. So we're going to have CuOH, and we'll come back to this, and CaCl. Okay, so if I look at my copper to start with, because copper is one of those elements that can form more than one ion, it was copper attached to 1 chlorine. Chlorine I know is a negative charge, and 1 negative charge. So that means copper had to have been +1. So hydroxide has a -1 charge, so I'm fine leaving it as 1 copper. Looking at my next one, calcium chloride. Calcium has a 2+ charge, chlorine has a -1 charge. So I'm going to need to put a subscript 2 after the chlorine to double my negative charge. So now that I have my neutral ionic compounds, I'm going to go to balancing my reaction. So copper, there's 1 on each side, that's fine. Chlorine, I have 1 on the reactants, 2 on the products, so I'm going to need a 2 out here. Which means now I need to fix copper, so I'm going to put a 2 here. And then calcium, I have 1 on each side, and hydroxides, I have 2 on reactants, and because of the big 2, I have 2 on products. Okay. So, your extra credit opportunity for today's lesson. This should be a little 3, just so it doesn't throw you off. But you've got 3 possible reactions. If you K-mail me the completed balanced ones, I'll throw some extra credit your way.